If something is symmetrical to the x-axis, the y-coordinates are the complete opposite. The x-coordinates are exactly the same. Your x is just repeated. It is not a function. If you have something symmetrical to the y-axis, your y values are going to repeat. That's fine. You're just going to have one input and an exact opposite that matches it. Now remember, if something's called symmetrical to the y-axis, it is also called an even function. Something can only be even if it is symmetrical to the y-axis. And then the last one is going to be the origin. And remember, if something is symmetrical to the origin, both signs change for an exact opposite. And that is going to be considered an odd function. So easy to remember because both of those words start with the letter O, odd and origin. All right, as promised, I was going to do some of your work. Let's do number 11 together. So number 11 is going to say y equals x squared plus 4. And I'm going to keep it color coordinated with those colors that I just used. All right, so here's the deal about symmetry. Sometimes it'll be symmetrical to 1, sometimes it'll be symmetrical to none, and sometimes it'll be symmetrical to more than 1. So you always have to test 3 times. I'm going to test this equation to see if it is symmetrical to the x-axis. So if I'm trying to analyze and see if it's symmetrical to the x-axis, then all I have to do is plug in the opposite letter with the opposite sign. I'm looking at the x-axis, so I'm going to plug in a negative y value. It's always the opposite letter. Notice there's my original y. I'm going to put a negative y in its place, and I'm going to copy the rest of the problem. Now, that's just a plain negative y. That's all that is. I will know it is symmetrical if I had to do more work and I ended up with the same exact graph or function that was printed on your paper. This does not match what's printed on your paper. The signs are not the same. It's all about signs, positives and negatives. This is not matching. This is not symmetrical. And I'm just going to abbreviate. Now I'm going to test for the y-axis. Just a moment. So when I plug in for the y-axis, I'm going to plug in the opposite letter. So y-axis. This time, remember, I'm trying the y-axis. You plug in the opposite letter. I'm focusing on the x. So I'm going to drop in negative x. Remember, it's squared. Now, if you notice on this problem, I can simplify that. Remember, any negative to any even exponent turns into a positive term. So, even though it's a negative there, I know a negative times a negative is a positive, for sure, 100%. So, that term is just like this. Negative times a negative is a positive. So does that match exactly what's printed on the paper? Then this graph is symmetrical. And don't forget, it's so special when it's symmetrical to the y-axis, it has the name of being an even function. So I saw a hand go up in just a moment. I'm going to answer that. Let me do it one more time with the origin. So remember, the origin is in purple. I'm going to try to keep it all color coordinated. The origin's crazy. You have to switch the signs of everything, every letter. So that was a positive y. I'm going to write a negative y. That was a positive x. I'm going to drop in a negative x. All right, so on the left side, I don't have to do any cleanup. That's just negative y. There's nothing else I can do with that. However, again, same situation here. A negative times a negative is for sure a positive, and then plus 4. Does that match the original? It does not, so it's not symmetrical. So that's how we're going to try this. I'm going to do a couple more with you. Just remember, when you test for symmetry, you plug in the opposite letter. Okay. All right. Number, I don't know, what else did I add? 12, right? Are we doing 12? Let's do 12. It'll be fun. All right. So problem 12. Great problem. Pay special attention to this one, because this one ends up being symmetrical, but it's kind of in disguise. All right, so this is y equals negative x to the third minus x. Okay. So I'm going to try the x-axis first. Now remember, when I try the x-axis, I change the y. The y was positive. I'm going to make it negative, and that is the only thing that changes. So does that match what's printed on the problem? No, it doesn't. It doesn't. So let's just make sure it's for sure not symmetrical. Now look, remember with math, you can move things back and forth all the time, all day long, across the equal sign, as long as you change the sign of the term. So I just want to make sure that I'm set on this. I'm going to move my y to the other side of the equal sign. That way it'll be positive, and then I can kind of analyze again. So they're all getting flip-flopped. So the y was on the left. It was negative on the left. It's going to be positive over here on the right side. I'm going to move this stuff too. I'm flipping it all around. Both of those terms were negative on the right. When I move it across the equal sign, it's going to be positive on the left. I just want to double check. My y's match, but look, I wasn't able to get my x's match, and it has to be exact. So I am totally confident that this is not symmetrical. All right, so let's try the y-axis. So remember, for the y-axis, I'm changing the x values. So y is going to stay positive, but I'm going to drop in some negatives here. Okay, here we go. All right, so when you raise a negative to an even power, it's positive. When you raise a negative to an odd power, it's negative. But when you raise something to an odd power and it's got a negative out front, it's positive. So this term right here, this is a positive term, because you have 3 negatives right there and you have 1 more on the outside. So this is going to be positive. What does this turn into? That's going to be plus x. Does that match what's printed on the paper? No. And if I try to flip my terms around, it still wouldn't match, because then y would be negative and then it'd just be a mess. So it is not symmetrical. That means it's not even. All right, crazy origin. We're going to change everything. So the y was positive. Let's make it negative. Let's drop in negative x. We're going to use our parentheses again. Remember, parentheses are our friends in pre-cal. Okay. So I'm just going to bring down the negative y. I can't do anything with that. But guys, the math doesn't change. We just did the same thing over here in red. Well, I was using red. When I plugged in a negative x, that's just going to turn into that. It's just in a different color for me. So this side turns into x to the third plus x. So if you notice, y'all, it doesn't match, but see how every single sign is opposite? If every single sign is opposite, then it's symmetrical. Everything's just on the wrong side of the equal sign. So let's move the y to the right side of the equal sign, make it positive. Let's move the x's to the left side. Let's change those signs. And I am so confident that this is going to match. Indeed, it does. So this is symmetrical. And don't forget, if it's symmetrical to the origin, it's special and it gets another name. What else is it considered to be? Odd. Yes, please don't forget that. That's how we test for symmetry. Let's do it one more time because I told you I was going to do 14. Let's do 14. All right, so 14, x equals negative y squared plus 4. All right, my 3 tests. So just going to replace the y with a negative y. Look at that term with all these negatives. Is this going to be a positive or a negative term? In there, a negative times a negative is a positive. But look, what does it end up being? It does. It ends up being negative. You have 3 negatives there. You have 1 on the outside. That counts as a negative. So this ends up being just like what we started with. So this is symmetrical. And it's not special to us because it's not a function, but that's okay. I mean, it's still symmetrical. All right, so let's try the y-axis. So here's negative x. Is there any way I could flip that upside down? Can I move the negative x over here and move negative y squared plus 4 on the other side? Would it match? It wouldn't. Because if I move the 4, then it would be negative, and that's not what the problem says. So we know it's not symmetrical. Let's try the origin. So we're about to change all the signs. So if you notice, this ends up being negative x equals, remember that turns into a negative y squared plus 4. And there's no way that I can rearrange to make that x positive without changing these signs. So it's not symmetrical. so that's problem 14, and that's how we test for symmetry.